Hi, good evening, everyone. Welcome to the initiative called as Saturdays for Sustainability Learning. And if you have joined for the first time, this is a community, this is a group where we uh, have a goal to discuss sustainability topics to understand in a holistic manner. And why and what is this group about? So you can consider this as a mastermind group. What we do, so mastermind, it's a peer-to-peer learning, peer-to-peer mentoring, helping members to solve the problems and getting inputs and advice from other groups. So if you have joined, so next 60 minutes, you can expect learning new concept every week, learning from fellow professionals, networking with fellow professionals, uh, more learning, more career opportunities, and thought leadership. Of course, where we want to take sustainable development, sustainability, that's something we would like to steer India and world towards. So these are the four outcomes that you can expect from this valuable 60 minutes. Two foundations to explain this initiative is one is DIKW pyramid. We have more data, more information in today's time than we can possibly consume. But what we lack is the knowledge and wisdom, the application part of it. And that's what we would try to get from these sessions. So this is uh, getting the wisdom, getting the learning from experience of all of us. The collective experience is much more than what we as an individual bring. So concept of synergy. And second is, of course, discussion and question and answer is one of the best way to learn. And I would also like you on this occasion to request you all. This is non-judgmental group, non-judgmental forum. So please feel free to add your experiences, add your stories, add your questions. Don't hold back. If you wanted to share something, please do so. And that's what adds value to the collective wisdom, collective uh, gain that we all can get from the session. And if you have joined this session, so I hope you have registered. And this is a one-time registration so that you will get the link on your calendar. So please do that. If you have done, uh, no need to do it again. So just one-time registration is required. So please do so if you haven't. And yes, back to today's topic. This is session number 81, and I'm very happy to introduce the topic and today's guest. Systems thinking is always one of the backbone of sustainable developments, sustainability. How do we implement this, right? So today's topic is introduction to systems thinking, what it is and what it is not. So there is so many misconceptions. And the second part is how do we apply it to the real world, real problems, real world, the situations and the problems that we face. And I'm very happy to introduce Dr. Sukanta Bhatt, who is Director, Tisory Consulting LLP. And he's expert in systems thinking and simplifying complexity in product engineering. He has been conducting workshops on systems thinking, and his work in complexity is really one of the phenomenal in India and world, I would say. And it's really deep gratitude, sir, for uh, joining this session as a guest speaker, accepting the invitation, and looking forward to learn from you the basics of systems thinking and how do we uh, bring it into action to solve the problems that we all have. Without taking more time, I would hand over the session to you, sir.
Okay, thank you. Uh, I don't have any PowerPoint presentation, so I want to keep it a dialogue to explore system and systems thinking. And the all our life, we from very childhood, almost anything we learn is analysis, right? Whether physics, maths, chemistry, everything is analysis, analysis, analysis. And so also the business world pick up analysis, daily management, Six Sigma, lean, morning a red light problem comes and by 2 p.m. they want to see it green. And somehow we got hooked to that reactive behavior, and it did. I mean, certain things also, good things also happened because of analysis. For example, if you recollect before antibiotics, like a lot of people used to die with simple infections. Right? So it's not like it's a bad thing. There are many things that also give benefit. And what is today we are enjoying the industrial world, the comforts, many of these things has come from analysis. Right? So certainly we should acknowledge that. Having said that, but somehow we, for anything and everything, we went to analysis and quick fix, and many of them have most of our problems are yesterday's solutions. If you reflect, almost every problem today we have is one of our solutions, a quick fix we tried yesterday, right? So, and the irony for me is I am, by discipline, I am a mathematics person. So you can imagine all my life, I have done only analysis, analysis, analysis. And then something happened just during onset of COVID. I we were a offsite management team meeting, and we were discussing problems and projects. And then after 2 days, same kind of thing. Oh, we are doing that, and from last time, what did we do differently? And our situation problems are similar. And then, like a joke, one of the colleagues told, "Hey, Sukant, you have a PhD. Why don't you find something?" I told, "Okay, sir." Because I have a PhD doesn't mean I know. But somehow I become curious. And then the next week, I little bit went to Google and I was thinking, what shall I search for? Then lot of time we give Gyan to our team members, think holistic, think long term. I put those keywords in Google. And then Google pop up something called systems thinking. And like any of you, I also start getting confused. Oh, is it design thinking? Is it system engineering? But then when I little bit opened, and then I was shocked. This discipline is there in the world for last 70 years, and I have never heard about it. And then, as usual, I like to do research. So I did digging in couple of months, YouTube and Google and other websites I hit upon. I thought, wow, such a fantastic things there. And I designed a small program and went to management. I told, hey, there is something called systems thinking, and I have designed a course for 2 days. And would you guys like to join? The senior managers, like they're always very busy. They told, I don't know what you are talking about. We will give you a group of freshers, 2 to 4 years. You try with them and see if that works, then we will think over it. And that is how the story started. And then we did. That was COVID, so everything has to be virtual. So I did 4 half-day sessions. And then the feedback session along with HR and L&D manager, they came and they asked each person, okay, hey, what did you happen and that. And the feedback was so crazy and amazing, the managers were shocked. So, for example, some kids told, you senior guys always give us gyan, think long term, think holistic, but you never told us how. This is the first time we've understood how to think long term, how to think holistic with methods and tools. So that is what surprised the managers. And then it got also, I got quite motivated looking at the outcome. And then I did a certification from MIT. It's a online learning system. And then that gave me more tools, methods, and process. And then I redesigned. And subsequently, next 2 and 2.5 years, because when you are in corporate, all the problems are real and urgent. So I conducted 6 real business problem solving workshops. almost 140 different level of professionals were there, and some of them gave some amazing results, just unbelievable actually. Mm. So that gave me the confidence, and then in 22 September, I retired from Philips, but I was so enjoyed and saw the power of this. I told, otherwise I'm quite more than a decade I have spent on software and more than 12, 14 years in medical device product innovation, mostly system engineering. But I decided I will only offer systems thinking, nothing else. So that is how the story started. And I started going deep. Then let's go in now. So first let's understand what is system, right? Anybody is aware of systems thinking? Can you put in the chat box or tell how do you define a system in systems science paradigm? Or raise your hand if you are aware of it. Okay, so I will tell. So system is a collection, right? Collection of elements. What do you call it? In our mathematics, you will tell set. Right? Set is a collection. And but a collection can be random. There may not be any relation between the elements or among the elements. But when a system, then there is connection between the elements. Not every element to element, but there is nobody sitting isolated in a corner. Every element in that set is connected to another element. Okay. But the most beautiful part is there is, it's not, it's just collection, but there is a purpose or a goal of that set. Okay. That's the most important thing when you define a system, right? So there is a purpose or a goal of the system. So when this happens, we tell that is a system, right? So let's take a automobile, right? So we have so many parts, right? Combustion system, braking system, alarm system, speed, right? So all various subsystems are there, and many components together make it achieve it, right? So they work in connections, right? The wires are not just sitting there, right? The cables are there, the mechanics is there, so they all are connected, right? But what is the goal of an automobile? Just tell whatever comes to your mind. What is the goal or objective of an automobile or a vehicle?
to transport,
Loud?
or move from one place to another.
Yeah, one place to from A to B safely, right?
Yeah,
That's very important, right? In our country, a couple of months back, the transport minister telling, though we have many roads, but one of our causality from the accidents is one of the highest, right? So it should take you safely from A to B, right? But the beauty is, say for example, in a system, there is no element, single element or two element can take you from A to B. So, so the individual elements do not have the characteristic of the automobile. So this is what is called in systems is called emergence. Something is more than sum of the parts. This is the very essential element in system theory. Okay. So it is something more than sum of the parts, and that is what in system theory we call as emergence. Right. And if you look around that, all around what you see, natural systems, human systems are all having emergence. For example, a human being, let's see one cell from your mom and one cell of her dad came together and some beautiful, wonderful or horrible characters are we are becoming, right? But that is not there in the cell, two cells. So something emerges which is much more than individual constituents. right? And sometimes good things happen, sometimes not good things happens. Both are emergence, right? In MIT's paradigm, they tell if good things is emergence, and if it's bad, it is emergency. Okay. So I take a pause here because this is very important to get it. If any question, anybody, please ask now so that you get the system.
Yeah, so request for all participants, please feel free to ask questions. Don't feel
Yeah, you
how
can
you
put
can
to the
ask
chat box
questions.
also.
Yeah. So whatever you are comfortable with, you can put it in chat. You can raise your digital hand or simply unmute and speak. Let us know. So I hope everyone is clear about what is a system and how do we know system from a random mixture. Yeah, Sony is asking, is this
Yeah, actually,
resemblance to computer system? Yeah, that's a good
yeah,
question.
computer system also a system.
So generally, a collection of things that work for a purpose is a system, and a collection of those systems coming together. Like for when you gave the example of automobile, right? There are multiple
Yeah,
systems that come together, and we still call them a system, right?
yeah, multiple subsystems are there. And if
Right.
subsystem also you can tell as a system.
Correct.
It has
Correct.
these characteristics,
Correct.
right? So be clear about the characteristics. Is
Mm.
it is a collection and there are interconnection between or among the elements and something emerges there is from that system.
Okay.
Okay, so
So the
these
consumer
three
of the
things.
system is not a part of the system, right? For example, if an
No,
automobile
is
I
not.
am driving, I am not part
Yeah,
of
you
the
are driving,
system.
you are not part, you yourself is a system, but you are not part of this automobile system.
Okay, I'll hold my other question to this
Sure,
for a
sure.
subsequent time. Thanks.
Yeah, okay. So this is what system. The another aspect of the system is there is a environment for a system. Okay, a system exists in an environment, right? So, for example, a automobile can be in a metro city. It could be in the village. It could be in a desert. It could be a very hilly place. It could be somewhere in the snow. So the other paradigm here is environment influences the system, right? So that is the thing. Many times things go wrong because one of the environment characteristic we either miss or we do not understand and did not incorporate into our system design. So that is where things go wrong. Many times where things fail, one of the elements from the environment we did not consider or miss it. Okay. So for any system, it will always operate in a particular environment. Okay. So system and environment go together. Okay. So now it could be, for example, your whatever city you are staying, for example, a traffic, right? So traffic is operating in an environment, it's a, for example, metro city environment, or it could be a village, or it could be a highway, or it could be a bylane, right? So there are different environment. For example, a bylane may not have the width for a bigger truck. So the environment is influencing the truck. It is restraining, right? But it influences. So environment a key factor in system. And here we are discussing industrial things, but it is also true in social problems or social systems. It is also true in all the systems in the so that is what very important to establish. Is it clear what is a system in system theory? It's a collection. There is interconnection between the elements, and from that something emerges. Okay, which is the emergence characteristic will not be there in any one particular element of the system. Altogether, only it can happen. For example, in automobile, you take any part that cannot take you from A to B. all together, put together, the emergence property happens, and that can take you from A to B.
Whether these elements will change because of this emergence or the elements will
No, no,
continue
no.
as it is.
Emergence will continue because emergence together, elements together bringing you this behavior. Okay.
Okay.
Another classic example of this is a caterpillar to a butterfly. That is a very classic example or story that is told in systems people. Is look at that when it starts. You do not even want to touch or look at it around that. But look what a beautiful creature or butterfly comes out of that. Right. So when you now with this lens you look around, you will be amazed that whole world, whole universe is full of emergence. Everywhere it is emergence, emergence, emergence. And of course, sometimes emergencies. Any question here?
No, sir,
Okay.
not for now.
Yeah. So one more thing in system theory, we tell with system is to really, for example, if you are doing this is a sustainability group, right? Experts are there. So there are okay. Let me give little historical background of this system theory. So it started in Europe in I think 1937 by a biologist. Okay, so his name is yeah Ludwig von Bertalanffy. So he was a biologist and he gave the name a general system theory. So that society is now 70 years, more than 70 years old. So it is renamed as International Society for System Science. Okay. And then around 1956, I believe, is there was a scientist in US called Dr. J. Forrester. Many of you might have heard about him. So he he was working in the warfare in the Second World War and electronics and that. And then after that, he came back to MIT and joined Sloan School of Management. And he started a systems science, I call system dynamic department there. Okay, so in US, if you tell he is the father of systems thinking, but if you go historically, Bartolomé is the first person who brought in. And in UK, University of Hull, who host, I mean, a lot of experts are there, and in US MIT, and they focus more on system dynamics. And this is sustainability group. If I will throw a name, let's see, if it rings a bell in you. Have you heard of a book called Limits to Growth?
Yes, heard through Dhananjay only.
Limits to Growth. So that is the classic book where there was a person called Dr. Tonella Meadows. So J. Forrester has many students, but four were very, very world famous. So Donella Meadows is one of the persons who work on sustainability. I mean, she is possibly one of the first to model and showed how industrialization is impacting adversely to environment. And she has done a fantastic work. Her website, I would very much suggest people to look. Okay, so it's there for almost now 70 years. So that is how they started. And then, and I'm connected to a lot of groups in the world, and many of the system sustainability groups practice system thinking quite deeply. Actually, that's my awareness. Okay. Okay. In between, you can ask anything. I want to have a little dialogue in this.
So there
I
is
have one
also this
question. Yeah, Chit,
sorry,
please.
I'll go ahead. I've also heard Peter Senge in many of the systems thinking world. Is what's his? He was. I think they call him system scientist or something. What's
Okay,
his
fine.
contribution to
So,
this area?
oh yeah, he has done an amazing job actually. Pragya, would you like to tell? Because you have attended his workshop.
Yeah, I've attended
I will just,
several of his. I've
I will
attended
just,
several of his workshop. Can you hear me? Yeah.
Yes.
yeah, I will just put two lines and then you can add on.
Yeah. I'll take 30 seconds once you're done, Sukanto. I mean,
Sure, sure. Yeah. So, as I was mentioning, there were four very well-known professors from the
Ed
Forester.
Shine was
So,
also Forrester student, right? Or not really?
I
Edgar
don't
Schein,
recollect.
did he not? I think they all work together, maybe, with
Yeah,
the whole
could be.
culture work and all.
Right, right. So,
Maybe not.
yeah, where was
They all
I?
work together.
Yeah.
Forrester
So,
student, J. Forrester's students.
yeah. So,
Chris
so Peter
Argyris.
Sange is one of his four students, along with Donella and other two. And Peter Sange made systems thinking world popular with the book called The Fifth Discipline.
Right.
Okay. And I think the first publication, quite a large, I think 1 million copies were sold or something. But that is where the world came to know of systems thinking. And then after 20 years or so, it was followed by another book called The Fifth Discipline Field Book, where there are many contributions from industry leaders. And for every section, there is a case study. So you can really see the application of each and every concept and how it is used. And he also conducts many other workshops, which Pragya is aware of. Maybe you can add, Pragya.
No, I think Sukanto shared my exposure to Senge came because of the fifth discipline work, which is organizational learning, because I'm an organizational psychologist and I work in organizations. So if you haven't had a chance at some point, just Google it and you'll find fifth discipline, 5 disciplines. And Sukanto and I often talk about it, mental models and personal mastery, mental model, shared vision, team learning. And then the fifth element, of course, is systems thinking. So that's one element of it. But he brought a lot of it into organizations. He did a lot of consulting with corporates in America. And now Peter works mostly
Big
with
time, actually.
education, because they've moved that. And then Peter's work has been carried forward by one of his students, and they all kind of work together. So Jay Forrest, of course, Dana Meadows, but then also Senge, Edgar Schein, then also Chris Argyris, a whole bunch of these people who gave some of our fundamental thoughts like dialogue. Dialogue as a model, advocacy, inquiry is very important to systems thinking.
Right.
As
I will
tools.
pick up that thread from
Yes,
Pragya,
go
and I
ahead.
will now
That's it.
little bit touch upon systems thinking. So we just understood system, right, in a system science paradigm. Now we'll go to systems thinking, right? So system thinking fundamentally is a perspective. Okay. So we do as I started, see, everything we were taught is analysis. But then there must be something called synthesis, right? And all of us, as unconsciously or consciously, are system thinkers at some point or other. That's what I have discovered with particularly people who have 10 to 15 years experience. Many of them have used unconsciously these concepts. Okay. So, and fundamentally, it's a perspective. And I also like it is very close to Eastern philosophy. Okay. So for perspective, in our culture, we have a very beautiful story, right? Six blind men and the elephant.
Yeah.
Right, every kid knows it, and it is there in every school, and we unconsciously always refer to that, right? and everyone is thinking he or she is correct. That's what our worldview is, right? So that is fundamentally what is systems thinking. It is a perspective. So how can you have a little holistic perspective so that we don't get that blind man symptom, but little step back and look at the bigger picture, right? So that is the very key concept here in the systems thinking. Okay. So so then there are um, interconnectedness. We saw that, right, when you are looking into a system. Okay. So the emergence is primarily what you are interested in. Okay. In system thinking, we are looking at, hey, how best we can manage emergence. And if you little bit reflect, anything or anybody is doing to achieve a goal is fundamentally trying to get the best emergence from the system. We are all paid to get the best emergence from the system. Our job doesn't matter what you do. If you little step back and see, it is the emergence you are trying to manage to the best of it from the system. Okay. So many times you have to stay with the system. Donald Madras has put very nicely, stay with the beat of the system, and the system will reveal itself. See, many times it would have happened. You are struggling with the problem again and again and again, and suddenly you get a flash, right? And in this system thinking is applied to largely complex problems. Okay. Now I will ask you a question. In recent times or recent past, what is one problem that kept you awake? Okay. Please put in the chat box. And then you collect it and put in a word clouds. Let's see what it looks like.
Sure.
Please do it in next 30 seconds or 1 minute. One problem that kept you or keeping you awake. Let me see what is coming in the chat box. What is one problem that kept you keeping you awake? Be specific. Then it will be fun. Indifference towards waste management. Okay. Anything. One problem that kept you in the recent past or keeping you awake. Okay, Achyut is a heavy man. Okay, tariffs. Yes, a lot of people not able to sleep. Come quick. We have a lot of things to discuss.
Yeah, for most of maybe business or work related. But yeah, please
We want to see it.
share your
Just 2 or 3 words. There are others. Don't see it. Others are very happy people, looks like. Everyone, please put. Dhananjay, are you seeing more? Because I saw only two or three.
Yes, sir. I'm only saying one, two, three, four. Yeah, everyone, please share. What is one problem that you
Kept you awake or keeping you awake? That's very important. Otherwise, you don't need system thinking. Okay, now I'm going to ask, since you are possibly a little shy to put, so you all have mobile phones. So find out something called wicked problem. You can go to Google or AI anywhere. What wicked, WICKED, wicked problem. What is a wicked problem? Next 1 minute, you should get back and tell what is a wicked problem. Because then you will really get a hang of sustainability and see whether these characteristics there in the problem that you are tackling. Now, don't write it. You go to web or wherever and find out what is a wicked problem. Definition of wicked problem or characteristics of a wicked problem. Then you can put in the chat box. Did you find at least 3 or 4 characteristics which makes a problem wicked?
Yeah.
At least 4 characteristics are there. So those are the mostly we use system thinking for wicked problems. And sustainability is very much one of the wicked problems. Yes, Achyut is correct. So, okay, looking at the time you do it for yourself. So, most, if you see today's, many of our problems are there are no agreement, there are different stakeholders, the environment is changing, and lot of disruptions, right? So that's has become a life actually today or last from the big industrial days happened, and there is no easy solution, right? And particularly when you go to sustainability, I've seen in the organizations, at least when I 10 years, 15 years back, we have a sustainability engineer, and then that guy is pulling his hair to get the data. Hardly anywhere anybody understands or willing to give it. And if I recollect, certain parts, one action was taken was to reuse the packaging material of the big devices when it is transported. So there's a lot of plastic, right? But then if there is something, a metal, for example, lead, right? And in some devices, that is a key material that is used, but that is quite toxic. So to reduce lead was another discussion, at least when I was there, and it was not an easy discussion and not very easy to solve. So like that, lot of today's problems, if you see, is of this nature. So these are very wicked characteristics, very complex. So that is where we system thinking gives a better way than analysis, because analysis you will go for a quick solution and then the problem will recur very, very quickly, right? So system thinking is exactly, if you want to tell, opposite of what we are doing all our life, right? It is much more holistic, look long term, look sustainable, work with people, listen, and deploy solutions. And there is no quick solution it will come. So you will also go through the iterations, right? So another 3 points I want to bring out. Okay, when things are connected, right? So couple of behavior you will see. Okay, so one thing is, in complex systems, delay is inherent in complex systems. Okay, I mean, you guys are in sustainability, you know how fast or slow things move there, right? All complex systems will have delay in its characteristics for various reasons. When you sit back and think, you will know, okay, from where delay is happening. But delay is inherent in complex systems. Okay. Second thing is where the impact will happen, right, from A to B. So we don't do YY analysis here as a fishbone, but we do that YYY and try to find out whether it's a causal loop. So we try to discover loops rather than a fishbone. And the loops will tell a story. And system theory will tell that those are archetypes. Okay. And there could be many, many, but there are 8 archetypes very well known. Okay. And these archetypes will tell the behavior, how the system will behave. Right. So this is the second thing that will happen in complex systems. And the third thing is, many times the effect, because our human thinking is 2 plus 2 called linear thinking, right? But in complex systems, the A to B impact many times is non-linear, right? The impact is much more than what you think, and many times you get surprised. And most of the projects, that's what happens, right? So a lot of assumptions we have, and we assume this is what will happen, but something completely different happens. Okay, so these are some of the characteristic you will see in the complex systems. Okay. Okay, I will take a pause here. We have 10 minutes, so I will take some questions.
Could you please repeat what an archetype is?
Archetype is a pattern. It is a, when you do a YYY of about your key variables, right? So then you will see certain certain loops. Okay, so there are 8 well-known loops. So these loops are called archetypes. Okay, so Dhanjay will share some reference material. You can have a look when you go back
Okay.
and do some more studies. So just another thing I want to tell is I am studying systems thinking now for 4 years, and possibly I don't know how many thousand hours I would have spent to that. So what I would bring out or suggest is spend a little time every week to uh, get into systems thinking. Okay, it will take at least 3 to 6 months to get a good hold of it. You practice in between, but it's a maturity journey. Even that happened to me when I went to the training. But that is one thing. The second thing, what I would suggest is now do a structured program now with Coursera or many platforms are there. So within 500 rupees, so you will get one or two decent course. Okay, so that will give you a structure process and detailed steps how to go about it. Okay, because I have also done a certification from Open University UK. So that's also a quite intense program, but you will get a feel of how European approach to systems thinking. Okay. The third thing before I forget, I want to tell is UK government is a very how do you as part of their process they apply systems thinking. Now you go to Google and please search UK government systems thinking case studies. UK government systems thinking case studies. All types of cases, problems they have tackled with systems thinking. Okay. And then, yeah, if I want to tell my story in that, yeah, case study, right? Yeah, that is the one. Actually, they're all civil servants go through the systems thinking program, as I understand. Okay. So, yeah, people can don't open anything, but yeah, since you showed, they can look for themselves. But yeah, okay, then this one, let it come. Yes, every kind of case studies are there. Very good job they have done. So India also some social organizations. I saw the School of Economics or somewhere some case study, but UK is at least very nicely structured here. Okay, so and if you start practicing and slowly, it will take 3 to 6 months to get to a good result because these are you are tackling with complex problems, right? And not just something you can do by mathematics per se. And there are a lot of tools also you can do modeling. Okay, so now with AI, the YY finding has become a little easier because you can go and ask, hey, this is my problem. Tell me different reasons why this is happening. Okay, and that gives you that output from the LLM, and then there are tools you can put it, and it can show you the loops. So it has become quite easier from that point of view. But initially, I would suggest you do yourself because the learning maturity will happen. Okay, tools are there, but go little later. Okay, the third thing before I close, I hope many of you have children, and Donella Models, I believe, started a program for class 1 to class 10th or 12th. It is called clexchange.org. clexchange.org. So it's called Creative Learning Exchange. Okay. You can go to YouTube and see this and how children are modeling their problems in the school or in the garden or around them so that when they are adult, they can tackle much more complex problems. So in all my workshops, I tell if not for you, for your children, you learn it, and they will be much better, absolutely, much better individuals and human beings. So this is the K12. Anybody with that 1 to 12 can register there. And I am really there is one more is water center. So they also are doing a good job in this space for children. So this is the start. Then you discuss and think over how you want to take it forward.
Yeah.
But these are some references or the good starting points. So one more place where you can go is where did that co-creating learning? Yeah, the systems thinker. Right, I'll put it here. This is possibly everything you want to know is there, and they are some of the real gurus and practicing for I don't know how many decades. Many times I go there and see. And also you can see donellamados.org. Yeah, system thinking
Yeah.
resources. Right. So I put it.
Yeah. And Donella
Uh,
Meadows' book, the basic book of systems thinking. So that's also a wonderful resource.
yeah, see also a book,
Anybody would like
system
to,
thinking a primer. That is one of my favorite
yeah.
books, other than Peter Senge and others.
Seeing systems, right? Is that what it is?
Yeah, thinking in systems.
Introduction to, yeah, thinking in
Thinking in
systems, a primer. Yeah.
yeah. So I mean that's a really a lovely book and a website. Tons of material, fantastic material is there.
I think systems, if I'm correct me if I'm wrong, sir, but I think systems thinking needs to be studied by heart rather than the brain. I think more with the heart, you know.
Yes, 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 absolutely. But one puzzle I have, it is 70 years. Why our B schools are not teaching it? And they are not
Yeah,
even aware of
that's
it.
so I not cracked that puzzle, but what I feel strongly is, you know, that we are so addicted to learning in isolation, right? We have our subjects taught in the history. First, a history teacher will come. Half an hour later, a geography teacher will come. When all these subjects are so connected, they can be taught in, you know, together. Also, if possible, that, you know, how they are all interconnected. But one reason which is, you know, many times have been quoted many times by many people is, I think it's our entire education system is devised by the Industrial Revolution. So I think
Yeah.
that
So
specialization is something which forced everyone to focus in isolation
yeah,
rather than thinking systems.
yeah. Okay. So Dhananjay, can
Yeah,
you put that
that's
latest case study or my one of my best results of applying system thinking in the chat box?
Sure, sir.
And then people can see
Sure.
that is I was super happy with I mean that's an amazing thing happened actually. I had no clue what will happen when I started the system map. And we went on for 4 hours and really a magic happened. I'm really, really super happy with that. That is a real life thing.
Siddesh, on what you were saying about management schools not teaching, I wonder, it's just a thought that I know in the social world, I mean, in organizational change in organization development world, because as Sukanta referred or somebody brought up, you know, Peter Senge's work came in, so organizational learning. There we do talk about systems, but those are all social systems. Now, Sukanto's work is really systems thinking for problem solving and product development, which actually should lend itself really nicely to
yeah,
engineering. And most
yeah.
Indian business schools are full of engineers only. Engineering has become sort of the basic BSc degree, no, some years ago. So I wonder why it didn't pick up, actually. Good question, Sukanta.
Yeah, so
Something to
I,
ponder.
I was happy that Singapore Institute of Management is teaching it for last 30 years.
Because maybe Daniel Kim, you know, the whole went there
Ah,
and
okay.
influenced it, right? Because he's from the systems thinker, that whole group, right? So I
Ah,
wonder
okay,
whether
okay.
that
So
was, he had some
he
influence there.
must
He's
have
been
worked
there
for a
for so
year
many
or two
years.
there and
The
right.
whole soul,
So
right? Society for Organizational Learning, the
organizational learning,
global
right.
soul, that also disintegrated. So anyway,
Yeah, so
sorry.
so I've just put one of the things with a client I work, and then everyone was really surprised with the outcome. So yeah, so
Yeah, I hope you can see that. Right.
Yes,
yeah, it's
yes.
visible. So like 6, 7 times it has happened, but this was a big, really big one actually. Yeah, so that is where uh, I started getting convinced complex problem can have simple solutions. So at least 6, 7 of these kind of situations have happened in my workshops. And everyone was surprised. How it is happening? Well, because you change your perspective. One perspective changes, you see a different reality. Tools and methods are there, but what do you see? Right? So it is fundamentally a perspective. A different perspective is much more holistic and long term. So that is
And the
what
challenge
has
with
happened.
seeing the system, right? Sorry if I'm jumping in, but we've talked about this. The challenge with seeing the system, folks, is the impact of it is distant from where something is happening. So you almost have to zoom out and then zoom in. So seeing the system is the telescoping out that somebody needs to facilitate, somebody like Sukanto or somebody who's a group of people trained in it can do it. I mean, we've all trained in TQM methodologies. I think systems thinking can absolutely be embedded
Yeah.
as a
So
methodology.
you cannot go for these kind of problems like a Lean and Six Sigma method. It will not work. You have to really give time, give space, give your emotions, and slowly get into that. Methods tools are there, but don't go too fast there. First, get a good feel of the problem. So that's why problem framing itself many times it takes me one day with the businesses, but they will all want to jump. I told, hold on. I push back. So because the framing is the most important aspect of problem solving.
Mm.
So
Right.
is it
So
also
one question,
because we are naturally built to be problem solvers in by definition human
We are
beings are
not naturally built
thinking
problem
of
solvers. Our brain has evolved for survival, so we go for a very quick fix.
right
Ah,
use less brain resources and get to a quick solution.
Yeah, that's
and
our first
heuristics.
reaction.
and
Yeah, we use heuristics, no, all the time. That's why
Right.
this
Yes.
requires us to suspend because systems think about questioning your assumptions, mental model.
Yeah.
It begins with the iceberg, no? So then
Hmm.
that's the part that
Yeah.
becomes.
Okay, good. I missed the iceberg. Iceberg is the paradigm we use big time in systems thinking. What you see is a very little, right? But whatever actual reality which is making the behavior is under the water. So
Right.
we had put a iceberg picture in everybody's senior manager's desk when I was working with them.
Yeah, but I don't know why they put it there actually. Every consultant will put it, but the origin of it is systems, right?
Yes.
Questioning your own
and
assumptions, your
Achyut, I
mental
guess one
models.
more reason, yeah. With assumptions, it's very difficult, right, to question. And what Achyut you said, I guess one more reason would be in organizations, we reward those who come with quick fixes or the quick solution. We don't want to linger more on problem. We want
Beautiful, beautiful,
a solution
Achyut,
which
you
is
brought
quick.
out. So
Very
that
true.
is what we call structure influences behavior.
Right.
Mm.
So we have built structures in the organization that promotes the quick fix. We
True.
reward them, we promote them, and
Very true.
that and clap it and so many things. But then it becomes a demon after some time. But that's what here system theory, the big slogan is structure is responsible for behavior. So this is what we call a structure in system science. Very well
Nice.
said.
Not a
Yeah,
person,
I
but
still
structure.
remember very well what used to happen. I think it continues to happen nowadays too. If somebody slogs over the weekend, works some 40 hours and solves a problem, that person is given a big shout out and other things. Whereas another person who has thought through all the systems and did not create any problems will go unnoticed.
Absolutely. Because the
Right.
organization structure all over the world has become like that. The B schools are teaching that way, the behavior senior managers everywhere. That has become
Yeah.
a de facto methodology. So therefore, we are seeing this. Okay, thank you very much. Uh, again, I suggest, uh, we- for me, it took 3 months to very intensely when I was into this. So don't expect quick fix. It will not happen. You will be frustrated. But spend every week or weekend, an hour or two, play around, take a white paper and a pencil and draw, right? And slowly it will mature. Okay, apply one concept in a week. Okay, so then in 3 to 6 months, you will be able to at least start a small real business problems or environment problems or social problems, whatever is your space you are working. But don't jump into solution too fast. Stay with the problem. That is the most important thing. Okay, and see with this small concepts we discuss. See, you can identify that in that problem space and its environment. Don't forget environment. And again, I repeat, the fundamental job any of us are paid or doing is to manage emergence, right? So that is where we gave a couple of examples. So stay focused on the emergence and see what are the different elements contributing to that emergence. And then slowly you will mature into it.
Yes. Any other final comment from any of our participants, please, you can. And I'm sorry, I had to keep my video off because of network issues. Generally, I don't log in from other place. I'm at home, but today I had to be in another city. So I'm really sorry for that. Yeah. Any other final comment, please? Okay, you can
No
also.
comments, but a lot of gratitude for all the time that you spent explaining these to us. It's very neatly, succinctly put, sir. Thank you so much for making time and sharing this. I'll definitely be kind of looking forward to build my systems thinking skills. And
Yeah, so I would suggest go to YouTube and search for short video systems thinking. That's a very,
well,
very good start. So very quickly
okay.
you can pick up from that as well.
I found some interesting Coursera courses. Are they good
Yeah,
good enough? Okay,
absolutely.
will do. Thank you, sir.
Okay, thank you very much.
Thank you, sir.
Yeah,
Thank you so
thank you so
much.
much, Sukanta sir, for the
Okay, thank you.
session.
Bye-bye.
And one thing that I would be taking from the session is whatever you do in your work, what you said now, so whatever you do in your work, you are managing the emergence. So that's really something that hit me, and I would be definitely exploring these concepts.
Yeah.
But thank you so much, sir, for your
Okay,
time, and
thank you.
it was a wonderful session. Have a great
Okay,
weekend.
thank you.
Thanks, everyone. Have a great weekend.
Okay, thank you. Bye.